Hello, hey, hi everyone. Good morning, good afternoon, and good evening, everybody. Uh, so let's get started. And thank you for choosing the ZK tutorials. In the last class, we have seen some topics of introduction of HANA, what is R3 architecture. So today we will see row versus column store. Before going to the difference between row versus column store, firstly we will see what is row store. So, as we know, in our traditional DB, so traditional DBs databases are like Oracle DB, as IBM DB. So, traditional DB versus HANA DB, you can say this like that. And the traditional DB version, how do they store the data? For example, if you want to save the data of our sales order table, where I have fields like sold to party, sold order table, okay, ship to party, sales organization, like material, quantity, and amount. I have all those fields, okay. So if I want to store this data in a row store fashion, in traditional DB, how the system will store this data? So system will store order type. Let's say this one is OR. Okay. Let's say my sales organization. It will store the sales order number. Then it will store the material number. Okay. Then it will store the quantity. So it will store the material. Then it will store the quantity. And then it will store the total gross amount. Okay. So similarly, it will store the next record in databases in the sequencer. For example, this is my take it as my first record. Okay, this is my second record. This is my third record. Okay, and this is my fourth, fifth, sixth. So how the system is storing the records? System is storing the records in a sequential way. Okay, so similarly, it will store the next record in the database in the sequential memory location. Okay, and then subsequent next one and so on. So this is how traditional DBs store the records into their database system. Okay, all the records of the table will be stored in the subsequent memory location. Okay, so these are all the and how the DB will store the reports. Okay, so for just take an example. Okay, is it clear? Okay, so if I want to know about my sales, okay, then what my computer will do? If I want to know about my total gross amount, then what the system will do? So system will start traversing the data. For example, it will see here. Oh, here do we have our total gross amount? No. Then it will go to the next field. It will go to the next field. It will go to the next field, and so on. Then it will fetch our gross amount. Okay. So after this, what the system will do? Again, if I want to know the total sale gross amount, okay. So what the system will do? It will go to the next record, then it will traverse through all those records, then it will reach here, okay, to 800. Then it will again start traversing. Okay. So can you imagine to just calculate the total sales system? Okay, to calculate the total sales, system has to traverse all the data. It's not like that कि भाई we need total gross amount. What we expect it directly, it should go there. It should go there. But what the system will do? It's the process. Okay. What our computer will do? It will traverse to the all the records. So can you imagine if we are having 10,000 records into our table? Okay. Then the system have to traverse each and every record. Then it will fetch this our gross amount. Okay, unnecessary to just calculate the total sales. To just calculate the total sales, system have to traverse all the records. So if I will ask the computer, being the row store, okay, system is traversing all records, and this is very expensive for your computer. It consumes a lot of processing power and time. So that this is the big disadvantages of row store. Okay. This is our what row store. What it will do? Traversing all the records. Okay. However, if I will ask another question to my question, hey, give me all records, all columns. In that case, this is good, and the performance of the row is naturally good. Okay. If I want to fetch all those records, then it will may be good. Okay. Have you created any report? Okay. Have you created any report in your system which needs all records and all columns? For example, if I will take Mara table, Mara which is material master table. Okay. Mara material master table. This is very famous table in ERP. So how many fields does this table have? I think it may be having some. Okay, let me quickly open this. Okay, just give me 1 second. Let me log into the system. Okay, so this is my SAP system. So if I will go to the S11 transaction to my table, just take it as an MR. Okay. So if I will click on display, so just take look here. We are having for about 263. Okay, columns. Okay. So can you observe here we are having 263 in this Mara table. So did anyone have write any report where it will fetch all the reports and columns? Okay. For example, some fields are like MATNAR, okay, ER name and A name, PSTAT, and material type, MTAT. Okay. So if we even okay, so very less in the case. For example, even SAP suggests us to don't use select star for performance optimization code. If we will see, select star is never preferable from anyone. Okay, so it's very less in phone performance. Also we have seen it's written like never use select star from DB table. So because if we will fetch all the records and all the fields, look, it's having 263. Okay, fields, and if we will go to the reports, how many number of entries? Look, 21,000 entries are there. Okay. So how much time it will take to take? Okay. So if we will even write select amount from, in this case, the system will have to pass through every cell. For example, if what I want is, just take an example is, okay, if I want to fetch a material group, just take an, so system have to fetch, traverse all those fields, then it will give us the, this report. Okay. So is it fine till here? So in some cases, okay, many times the requirement is to fetch the few fields, not all the columns. We don't have to fetch all the fields, just some fields we need to fetch. Accessing few columns, then you may have requirement for calculating total, maximum, minimum, okay, and probably less amount of data. But even if you try to access less data, system has to traverse all the cells which is stored in the memory location. So if you want to fetch the less fields only, in that case also system have to traverse all those records. Okay, that's why we have came up with an approach which is known as column store. Okay, just 1 second. So for So this is what our column store. So while it has came up with this approach, because for fetching a single record only, single field only, system have to traverse all the records. So for after this is this DB has come up with new approach, which is column store. So what is column store? So column store, it's splitting the data. Just imagine every column, every column as a teeny table. Okay, so what we'll do is SAP say, hey, I'm not going to store the data in sequential way. What SAP said is, hey, I'm not going to store my data in this way. What? Okay, rather every column of yours is tiny table. So what he has came up with this column store approach. Okay, it means that for each of the tiny table, so I am going to store this data to these tiny tables. So how I am storing the data now? To these tiny tables, and that's our column store. So is it clear? To store, it means that for each of the record of the tiny table, so I am going to store this data to these tiny tables, and that's our column store. Okay. So here the first column is our sales order. Look, this is our sales order type. Okay, OR. So five reports are here. Now the second one is again 0001, and that's my sales organization. Third one is my sales. Okay, order is the order number. Take it as X Z Y Z Z O D. Okay. Then we have all the quantity field, the total gross amount. Okay. So this is how the data is stored in the column store. So here every column is a teeny table. Okay, let me write this. Okay, it's very important to have this. Uh, 1 second. Teeny table. Okay. So here every column is a teeny table, and this is how the database is going to store this data inside these teeny tables. Okay, it means that for each of the teeny table, I'm going to store the data to this teeny table. Okay, is it fine? Okay. Now look at the benefit of storing the data. Now what the benefit of storing the data in teeny tables? Okay, same question, because here we are having like this sequential way data, then here we are having in columns. So what is the difference? What is the benefit of this? Okay. So now if I will go to my database and I will ask again the same question, hey, how can you tell me that what is the total sales? So in this case, DB don't have to go to every team level. He don't database don't have to go to this sales order type. Then here organization, everybody here database don't have to go. What it will do? Okay. So in this case, database does not have to go to every teeny table. So it will directly go to this sales teeny table. Okay. And just process the data, calculate and the data and okay, calculate the data and get us the total. So what it will do? It will directly jump to this TNA table and it will give us the data. Okay, and just process the data, calculate the data, and then get us the total. Okay, so it does not have to do lot of processing of data without going to this TNA table. We have directly fetched the data. So system don't have to go to this every TNA table. Hey, I will go there and check. Hey, I will go there and check. Hey, so what it will do, system will directly jump to the this sales table. Is it fine till here? And because of this, I have increased the performance, especially when I need very few columns. Okay. So is it fine? So the next is it's possible to aggregate the data much faster because we don't have to. It's process. Let me write this. It's process to aggregate the data much faster because we don't have to traverse through all columns. Okay. So first advantage is clear. For example, okay. So the second advantage is that in the past to speed up the data, we need to create secondary index to speed up the data. For example, this is our row store. Okay. So we used to create secondary indexes to speed up the data. So to fetch the data faster, we used to fetch the data through primary key. How was we doing in the DB's select queries? Okay, so what is it will do? So to fetch the data faster, we used to fetch the data through primary key. And if the select query don't have the primary key, so for example, in Mara table, we are having the primary key as Metnar. Okay. Okay. So if I want to, I am writing the query of select. Okay. Here, if our field name from DB table. Okay. DB table. So if our select query does not having the key field, then what we used to do, we used to create the secondary index to speed up the data. So to fetch the data faster, we used to fetch the data through primary key. And if the select query don't have the primary key, we have to additionally create the second indexes. Okay. Now these indexes have some advantage and they again duplicate the data. So what is index? As a new word came there, what is index? So index is just nothing but 1 second. So index is just like your book index. Whenever you want to jump to any page on your book, what do you used to use? Index, which topic you are interested, and we can directly jump to that page number. We don't have to read complete through the book, go to the required topic of our database. Similarly, the indexes which store the primary key data and row, now basically the memory address of the record. Okay. Now before you look into the table, you just first check the table index. In the index, you find the record and keeps your row address and just jump to the row address immediately. That will basically speeds up the access of data. Now these indexes cost overhead. Why? Because they again need to duplicate the data separately somewhere else, and also means you need more storage to access the data. Okay. Look at this data. Every teeny table, look here at this table. Okay, look at this data. Every teeny table is an index. Okay, every teeny table itself is an index. So that's the big advantage. So the second advantage is in the row store, if we are fetching the data and the select query don't have the primary key, what the system used to do? System used to create a second index. But in our column store, every column is a every teeny column is a index itself. Okay. Now we don't need to create a secondary index because in column store, as I just told you, 1 second, column store, every teeny table is itself an index. Okay, index of itself. Now it will speed up the data. Suppose I want to read the fourth record. Okay, I want to go to the fifth sales order number. So can I can directly jump because every teeny table is itself is an index. So this will significantly reduce the memory of our print. Okay, of our output. So both the advantages are clear. So next, so came up with the next advantage. Earlier, if somebody wants to calculate the total amount, they used to store last amount in another table. And this is known as aggregation. Okay, so the calculate total value is stored in another table known as staging table or aggregation table. Okay, and this again need extra storage space, but now it's not needed. We can calculate it on fly. You don't have to store the total result in a separate table, and you can access this table much faster. Okay, now there is no need to store these aggregates in another table. Why? Because it is possible to calculate the aggregates. What are aggregates? Second. So what are aggregate? They are nothing but so what is aggregate? Basically, they are minimum to calculate the minimum. Okay. One second. Maximum. Okay, or sum or a count. Now what we can do in this column store, we can calculate these on fly. Okay. To calculate these aggregate, we don't need to store the data. It's possible to calculate the data on the go, or we can say on the fly, which means you can give real-time scenarios to the end users. Once again, we can give the real-time scenarios to the end user. So is this clear to everywhere? Okay. So the next advantage is compression. Look here, you can see the data is repeating. Okay. Here you can see the data is repeating. Also, can you see most of the column data is repeating? Is it happening or not? Okay. You can see the data is repeating at most of the places. Okay. Here in this place, you can see the data is repeating, and this is true in our ERP system. Okay, in our ERP system, it's common. Okay, so if I will go back to the Mara table and let me show you some of the data inside this. Just wait, let me open the Mara table again. Give me a moment. Okay, so let me go to the table. This is my Mara table. I'll go to the table contents. So you can see some records which are repeating. Okay, for example, here MBRSH, MMM is repeating. Okay, here in the MEINs, ST is repeating. Okay, so can you see some columns where data is occurring again and again? Almost every record have same data. See this? Okay, ST see this and see this. Okay, now in the row store, what was happening? Even the data was same. Row store have to store the data. Okay, every memory location in column. Column store we can change our approach. So what is the system will do in row store? What was happening? Even the data was same. Row store have to store the data at every memory location. But in column store we can change our approach. Just one second. Let me go again to our PPT. Okay, so here also if you can see, this is our ORs. What we can do here is OR, okay, and we can do it at one memory location, 2, 3, 4, and 5, and that's all. Now, can you imagine how fast your data is reduced? Okay, and as you see the overall big picture in ECC system, pick up any table, most of the column data is repeating, and you can go and check any table. Whichever area you are working, go and check in your system. Most of the columns is not unique, it's repeating itself except primary key, okay, or some other column. Except them, rest all them are repeating, and I don't have to store again and again. I can store at one and say, hey, what position they belongs to, that's what I have to do. That's it. Okay, it also having some intrinsic advantages which we will discuss now. Okay, so is it clear? For example, to store OR we can do, okay, and 0001 if we have, okay, and we can say, hey, at 1, 2, 3, 4, 5. That's it. For example, here I have X, and at Y we at how many location we have Y? Just one second. At two locations. So we can say Y is at 2 and 3 location. So if the data is repeating, what I can do? I can directly go and tell, hey, one second, Z at 4 and Z at 4th and 5th location. Okay. I think we don't have this. Same with this. Okay, same with this. We can do like this for every teeny tables. Okay. Is it clear? Okay, so now the question comes is, what does the computer process faster? What does the computer will process? Computer will process the words, or you can say as alphabet faster, or computer will process the numbers fast. Of course, computer will process numbers fast because the numbers are easy to convert into binary as compared to the character format. First, they will convert hash key, then to the binary key. Okay, they only play with numbers, so our computer can process much faster rather than comparing strings. Okay. So this one is clear. So here, what we have done, here we store our these records at the memory location, whichever are repeating. Okay. So it also having some. Okay. So is it clear? Okay. So that's all for about row store and column store. Hope everything is clear between the difference between this row store and column store. Now let's move to the differentiate between the row store versus column store. Simple. First is storage format. Okay. So it stores data in rows. Here it will store data in columns. For second is data compression, same, less efficiency compression compared to column. Okay, highly efficient compression. Okay, rule, retrieval performance, good for transactional workloads, excellent for analytical workloads. Okay, aggregation, same, maybe slower for complex aggregation. What are these? Minimum, maximum, sum, all those. Okay, then this input output reads entire rows even for specific columns. For example, if I want to know about this column, for example, this sales column, it have to traverse all those reports. Okay, but here you can see for the reads only the necessary columns, reducing input output is okay. So here, if I want to read this record, so it will do. It will not go to every Trinity table. It will directly go here. Okay. So here at the last, sorry, yeah, update performance generally good for individual row updates, maybe slower for update due to column store. So what here? So here in the update case, row store is good, more efficient than column store. Why? Okay. Why? Because here you can see we can update this. Okay, update this column more easily than here because we have to update these all the columns at first position. Okay, so here update performance is good in row store and in comparison to row store, column store is slower. Usage scenario, this is used in OLTP scenarios, transaction system, and this one is OLAP. We will see OLTP and OLAP in depth in the next coming lectures. Okay, SAP HANA implementation supports row based storage. This will primary storage format is column based. Okay, so is it clear to everyone till here? Okay. So these are all the differences between the this. Okay. So let's move to the next. Just one second. Yeah. So before moving to the next topics, we will see something more about HANA. As previously we have already seen the evolution of HANA, how HANA was. Okay, one second. Here we have already seen this evolution of HANA. Here, like in 1979, R2 came, and 1992, R3, then in 2015, HANA came into the picture. Okay, so we will see something more about HANA. Okay, so how it happened when new technology will come into the into the market, how then how anyone can accept easily. Okay, so how it happened when SAP HANA was introduced? So when SAP HANA was introduced, it was completely new. Obviously, SAP was like previously, but HANA was new because we was having our traditional DBs, Oracle DB, IBM DB, some other DBs also we have. So HANA was completely new, and then SAP says, "Hey, we have this amazing data. This is going to boost up your business, boost up your performance. Would you like to try out?" Okay. So, but when SAP goes to the market, then customers was using other DBs, which was Oracle DB, Max DB, IBM DB, and they was running their ERP system on the top of the DBs. So, what was happening at that time? Previously, ERPs was they was having their own DB, okay, traditional DB. Then why they will move it to the new DB? So, do you think the customers who are using their previous DBs they will throw this and start using this HANA DB? Huh? For example, we are having our phone in our hand. Okay, we are using one phone. Then the market salesperson will come. He will say, "Hey, this is a new phone in the market." So what you will do? So can you do it normally? Hey, I will throw this phone and I will take your phone. Is it? This is not possible, na? Would your company do this? obviously answer is no. Nobody wants to take risk. I don't know how that phone is. Okay, I don't know how the HANA DB is. Then SAP said, okay, bhai, don't do anything. So so just take it between like salesman and a customer. For example, I am a customer, right? Okay. So what it will do? I am having my mobile phone. I am having Apple mobile phone. So then Android one will come. Vivo salesman will come. He will say, hey, bhai, take this Vivo. Okay. So it's good. Okay. So what you will do? Normally, what do you think? I will throw my phone and I will take, hey, give me this Vivo phone and I will use it. This is not possible. Okay. And look at the company size. They are having their own DBs, traditional DBs, and SAP came up with HANA. So can they easily accept this HANA? Answer obviously is no. So then SAP came up with a new approach. They came with the new technique. What they said? Then SAP said, okay, bhai, don't remove anything. Let your system keep running on this DB. But okay, so this is our previous system, ERP system, and this is where the system they were doing. Okay. So what they have said, by don't remove anything. Let's keep your system. They said by keep your Oracle DB and this ERP. Okay. Okay, on the DB, but what you do, plug my HANA DB parallel to the existing DB. So what they say, just by plug my HANA DB parallel to your Oracle DB. You don't have to remove anything. What you have to do, just plug in my HANA DB. Okay, to your existing DB, and what you will do, just give me access to your current data. Okay, I will move your data. I will copy your data from existing table, existing DB. Basically, make a copy. Okay, I will make a copy of your existing DB to HANA DB. I will make the copy of your data from existing DB to our HANA DB. Okay, and then I will run some of your ERP reports. Then I will show you what performance boost you can get. Okay. I will run some of your reports and will show you what the performance boost max is to max you can get. So you can experience HANA. This is what SAP proposed. So tactics is clear now. So what SAP said, by don't remove your DB, whichever you are doing, just work there. Use your own DB. Just in parallel, install my I will install my HANA DB also, and I will copy some of your data to my HANA DB, and I will run some reports and then will show you. Okay, some customers are agreed to it. Okay, this is possible because SAP was providing something called HANA driver. So it's not normally ki I will put my HANA DB also to that, but how I am connecting this my HANA DB to the system through HANA driver. Okay, so HANA driver is just nothing but just a connected to HANA. Suppose HANA. Okay, suppose you want to draw some power. You want to charge your mobile phone. So you need to plug your adapter to socket. Similarly, to plug SAP HANA, there was a socket. That socket is HANA driver. Okay, so now it's possible to plug HANA to the existing system with the help of this driver. But still the primary database was previously which you was using. So you are having your traditional DB. I am just plugging in my HANA DB through HANA driver. Okay. They copy the data to just showcase the power of it, which means HANA was plugged parallelly, and this is called sidecar scenario. Okay, this is how they have firstly launched the HANA into the market. Okay, which means we are running HANA side by side. Okay, is this clear? Okay, so this scenario is known as sidecar scenario. Okay, so after this, SAP got more boost. Okay, so customers replaced their DBs with HANA DB. Okay, because what HANA have shown, they have run some reports to the HANA system and they have shown the performance. Okay, like it's obviously HANA performance is far better than these traditional DBs. Okay, as we have seen in the last also, like that row store and column store. So it's like that only. Okay, so what does this mean? Okay. Is it clear? Okay. So the now after this, they released their own project, which is Project Orange. So what does this Project Orange means? Okay. And they first enables SAP HANA running as a primary database. Here, how this HANA DB is? It's on a primary, sorry, secondary database. But after this, what they have came up with? They came up with Project Orange. Okay, they first enable SAP HANA running as a primary database. How? Fully SAP HANA running on the as a primary database on which system? On BW system. Because what is BW? Is business warehouse. Okay, BW is business warehouse system which is mainly intended to do analytics. Suppose just take an example, your last 20 years of data in your company, and now you want to you want to take the further direction of the company. You will dig into that data, do some analytics, and find out the pattern of our customers, or you can find what was the sales of any object during any occasion in the last 10 years. So in this project Orange, what just take simply what this have done, they have completely moved their HANA, sorry, BW. They've come, they moved, they made this HANA DB as a primary DB. Okay, for this BW, as BW is a business warehouse where we store the like analytics type of data, previous data we can store. Okay, sometimes we have seen you that in last 20 years or last 10 years, machine learning has grown fantastic. There are some more jobs created on ML. How do they look into it? How do they do look into the last 20 years? They look at the past data or past patterns, whether they do prediction of future. So SAP called this project as Project Orange. Okay. If you are on BW version 7.31, okay, and you are on SAP SP03, you can directly, at the time, you can directly run your HANA system. Okay. So is it clear? So interviewer may ask you which is the minimum version of HANA needed to run BW on HANA. So SP03 is the minimum version of SAP HANA to run BW. Okay, so it's basically becomes BW on HANA and also known as Project HANA. Okay, so is it clear? So after this, ERP database is also replaced with. After this, ERP databases are also replaced with HANA DB databases. So customers starting asking SAP to run our ERP systems also on HANA. Okay, that's why your entire ABAP system running on HANA DB, and that how become okay for what. Oh, okay. For what we all are here, okay. For what we are, that has become ABAP on HANA as a technology, okay. Running ABAP system on HANA, okay. Is it clear to everyone till here? Okay. So what is the difference between ABAP on HANA and Suite on HANA? So ABAP on HANA is a technology and Suite on HANA is a product, okay. And ABAP is a technology and ECC is a solution. Now SAP has made this HANA DP as mandatory, which means every product which they will launch, it will be only on HANA. Okay, and if you want any new product from HANA, then it will be on HANA system. So I hope this will be clear to everyone. Okay, so let's wrap up this session and thank you for joining. Thank you. Bye bye.